student work, and it's handwritten in the book. I don't have any student work to show you that's kind of like that, so I just typed it up for you to take a look at. And so what he has is sort of samples of student work and a particular kind of error. And so sometimes it's A, B, C, D, sometimes it's a couple that you can take a look at and see if you can spot the pattern. And then what he has after that is, can you then understand that error pattern well enough so that you can make it yourself? So that you can then kind of say, okay, so I know how this kid is thinking, and I know what that kid is going to do. And so then after that, sort of, how can we help that student, maybe not kid, but how can we help the student kind of correct that error pattern? So what's happening with A and B here in the top, and not, this is kind of bad, this is part A and this is part B, and these two things have nothing to do with those two things. Poor choice on my part. So like the A to the fourth, and then squared, and the answer is A to the sixth, B squared cubed, and then the answer is B to the fifth. And sometimes there's A's and B's in his work, sometimes X's and Y's. So what's happening?
So they're really thinking it's B squared times B cubed. They're just confusing those two rules.
Yeah. Yeah. So what do you do to kind of fix that? How do you expand education? Yeah, I mean, I think it's kind of exactly the same thing that Rich was talking about earlier. And I don't know, if you actually just sort of pick one of these and you say, okay, well, what is this on the left side? Well, this is the square, so do I say that's an A to the fourth times an A to the fourth? I multiply it together twice and I keep my parentheses. Would you start here, or would you literally like A times A times A times A, and then A times A? I'm a parentheses user. So how would you guys do this when?
I just taught that this year, and Lori and we've been kind of talking about this. I don't even teach with rules anymore. If the kids kind of figure it out, that's great. But we do completely expanded notation. And so I don't even show the first step you did of A to the fourth times A to the fourth.
So that one is gone, and
Yeah.
you just go down here first.
And if they start finding shortcuts, that's great, if they're consistent. But otherwise, I notice middle schoolers obviously just try and memorize rules, and then they get them all confused. So
I have them do the first step in my I teach lower level algebra, does that make sense? So they didn't come out of the honors classes. And so I do the first step first because they don't know what squaring means. And so if they don't do that, they have no idea that you do it twice. Like that's important to me for them to get that definition.
So depending on the way you started out, you might go either this first or that first, basically. Is what you're saying.
So I would do the first one first.
You would do
just
this
because-
guy first.
Right, because I would say we have to deal with that power, but.
Yeah, that's a good, I mean, I don't know which one of those is actually better, to be honest with you. I don't know if there's one, maybe it's based on where the students are, what, like you said, what background knowledge they're really coming in with. That's a good question. Anybody have any other, I don't know how many are teaching kind of the algebra versus kind of the steps right before that with like.
Well, it's always, for me, it's always easier for some of the kids in my classes, get rid of the letters and let's go to a number. If I said 3 squared, what is that? And most of them can say 3 times 3. And
So you would even kind of, I don't know where to write. You would start with something like this.
Yeah, because they can understand numbers and then jump to your letters.
Well, and then they find out if they think it's 3 times 2.
Right.
yeah,
Because they do, lots of them do.
yeah.
Right.
That's like my biggest error is
Yeah.
3
But
times
if you
2.
start with going numbers, they can make
Yeah.
the connections and then jump to your variables
I see.
and substitute. Then I might go, okay, what's n squared then? Okay, now n equals a to the 4th, and then,
Yeah, and go from there. So you start with a number,
right.
and then you say, okay, let's put a variable in there. and now let's put something even uglier
Now
in
put A
there.
the fourth in, so it's squared.
And let's just replace that. And I won't parentheses either. Like so you start, so that's really analogous task basically, right there, right? It's kind of building on all of that. And so this is how you really break it down for them, depending on where your kids are in that progression, and then either of these two, and then everything kind of. Do you kind of after that talk to them about just? Do you count the number of times it appears, or what's the language that you use? Because Rich also mentioned some things about language here. We have to be careful about the things that we say because they may overgeneralize.
I say, what's an equivalent statement? I use that terminology a lot in my classes.
I always ask them what exponents mean, and you talk about, like n squared means we have 2 factors of n. So if I have n cubed, that means I have 3 factors of n.
Yeah. So do you use the term, like with the n cubed, would you say n multiplied together 3 times, or would you say 3 factors of n instead, or do you use
I say
those
3 factors of n, so it's n, then it's shown with n.
So that you stay away from confusing multiplication and addition. If you say multiply together 3 times, they might actually then start thinking about addition instead of. Or they multiply by 3. You said multiply 3 times. I multiplied 3 times b.
But that's such a huge error. We just did almost exactly this problem in my AP statistics class because we were doing logarithmic transformations, and they couldn't figure out why you took the base to the power times the same base to the power when you were doing a linear transformation. And I was like, oh, good God. All right, so we're going back to what it means to add the exponents. So that whole piece was,
Yeah. I'm not surprised at all, because I was gonna say, even in differential equations class, which is what I'm teaching right now at 8 o'clock, 4 days a week, I kind of every now and then have to go back, and sometimes it comes out of, so this is a little off track, but we'll end up with something like that.
right, and that's exactly.
And so you wanna pull those 2 pieces apart and say, well, this is this times this, and then we say, oh, this is really just another constant. We can rename.
So it's an exponential
And we
function,
go in the,
which-
on with whatever, but I have to write this on the board a couple of times for them, because I think they're more comfortable going this direction, but then when you have to pull it apart, they're like, whoa, what, wait a minute. So I often have to say, okay, let me write this down, and now convince yourself going this direction. And it's really basically exactly the same kind of thing I think you were just talking about.
Oh, that's exactly the problem we just did today.
So we're all doing the same problem. Okay, so I should probably turn that back on. Do we want to talk about b to the 5th as well, or would you even do, so I'm going to go back to what Rich said earlier just a little bit. Thank you. Would you actually go over here to the statement that here's what the student actually said, and now would you actually have them expand this out and compare it with this thing? Or would you just say, oh look, well this is an a to the 8th, you've got an a to the 6th over there. I don't know, would you go both directions, or would you just kind of start with the left side?
You could probably do what Doug was saying and say, you have the factor of a 8 times, you have a to the 8th. Now you said it was a to the 6th, now that's really saying a is a factor, how many times are they equivalent?
Oh yeah, try those two
Make sure they
things.
understand both ways.
Oh yeah, that's a good idea. So you might go over here and write this down. If I don't run out of 1, 2, 3, 4, 5, 6. So good ideas. I like all of these. Specifically like this because then even if they're a little bit confused about their rules, maybe they can kind of get back on track with the rules and kind of rediscover it, maybe.
Well, maybe
Depending.
saying rules less is a smart idea. You know, maybe like Shana was saying, that we just need to say, what happens? What is it?
You know, what does it mean?
Like, let's go back to the definition. Let's talk about exponents as what they are, not as this magical bunch of rules that we work out.
We have to
Work out when we
memorize.
remember them.
But if it ever does come up that we talk about rules, there's great value into always writing it both ways. Because even think about the discussion Doug and I had during my talk, how come we didn't write it in the other order? You know, I think showing them all the rules both ways, to the point of just go up there and erase, go to the very upper left-hand corner
Uh-huh.
and erase a number, like erase the 4. And then maybe erase everything to the right of that equal sign. And then ask a question like that. I mean, if we're gonna teach rules, let's have them develop the rules left and right. Hey, what number goes up by that A? You know, it's not good enough to just say 8. And there's some thought process that goes in the 4, especially if Lisa were to erase those parentheses. But, so if we're gonna develop a rule that you multiply, we should test it, assess it, and check it with some division idea. So think of our logarithmic exponential idea, you know, yeah, they can't write e to the x plus c as e to the x e to the c, because their whole life they only did e to the x times e to the c is e to the x plus c. It's ridiculous, we take it for granted. But if a rule is presented, if a pattern is presented, there's great value in presenting it both ways. And someone's gonna discover the rule in your class.
Oh, absolutely.
So we have to make sure it's assessed appropriately.
Well, the other thing is too, they do need to go forward and backwards. Because if you would write 2 to the x
Uh-huh.
plus 2.
Over here.
Yeah, 2 to the exponent of x plus 2. Okay, you know how kids can't simplify that? They'll, I mean, they'll live like that, they won't write it as 2 to the x times 2 squared. They won't go backwards, but if you go back and show them, you know, b to the m times b to the n, and they can all get, well, that's b to the m plus n, but can they go the other way? If they can, they can do this problem. If they can't, they can't.
And we're still doing that differential equations class, I'm telling you.
Well, that just makes me think about in Algebra 1, they talk about sequences. And if you talk about geometric sequences and the explicit formula using the f of 1 term and the common ratio, but then you want to make the connection to exponential form, actually, it's hard for them to take it, because you can take it and move it to that form, but it's hard because you have to do that.
Because if you switch
Yeah,
that to
yeah.
a minus x minus 1 now, Instead,
Let's just put it
just go
over here.
2 to the x minus 1.
X, or 1 minus x?
Just
2
x
to the
minus, yeah,
Oh.
2 to the x minus 1. So basically your ratio is 2, so you can have, you know, g sub 1 times r to the x minus 1 power. So there's your exponential equation, or, and a lot of kids can't simplify that to 1/2 times 2 to the x.
Yeah, yeah. Yeah, I wasn't sure if I should bring up negative exponents in here. I wasn't sure exactly where everybody was in terms of, I don't know.
Standard.
Well, in 9th grade, when we get there, I mean, we make that step, and I still have kids, at least in my lower class, that just, they don't get that, they don't.
Once because the exponent is negative, they're really kind of.
So they'd rather go to the table and find the 0 term and work backwards that way and just put it in exponential form and know that instead of.
As opposed to just doing an algebra step. Just one.
Will anybody tell your student like it's divided by 2, like a half? Because a lot of my students, they don't understand it's divided by 2.
Yeah, we talked that
Yeah,
you
it's
can
like-
also rate this as a 1/2
Half
times
x.
the 2 to the x.
Yeah.
I don't know, I usually tend to get rid of negative exponents pretty quickly, but I like fractions, so I'm not sure if that's the thing that you guys actually think works best in your
Yeah,
classes
they need to
or
do
not.
that to simplify it, to get your, you know,
Your
explicit.
ratio.
Well, to get your explicit equation, you need to simplify it, and a lot of kids struggle because they can't simplify it. Because they can't multiply the 1/2 by your g sub 1. If g sub 1 was 6, then they don't get 6 over 1/2 times x times 2 to the x. So they don't get the 3 times 2 to the x then.
All right, so I think probably we should go to the next one. Oh, wait, one more back. And this is really kind of a continuation of the other one, sort of. There's a couple of things going on there. So what are these, what is this? But they're also not
That's in the number.
Well, because the 2 doesn't have an exponent, we
Yeah.
don't want to add anything to it, they're a little concerned about that.
Yeah. Yeah. Yeah, so there's multiple things going on here that need to kind of be. If they were consistent. Yeah, and it could be because, well, the x and the y are different than the 2, you know, somehow. They're variables or unknowns, and the 2, well, the 2 just doesn't count in the square somehow. And you guys probably see this a lot, pretty standard.
I would see a lot of 4s and 6s or 9s in the front. They would do something to the number,
Maybe
it might not be the right
It's
thing.
fairly consistent though, right? So I mean,
Yeah.
at least in my class, if they're, for example, if they get 2x to the 5th, that same student would usually get 4x to the 5th.
Right, and you wouldn't know whether they squared the 2 or whether they just thought it was 2
Right.
times the exponent.
But typically it'd be
which
the
is
same
2 6,
operation.
but-
So in the next one, maybe we could see that if they added the exponents, they'd add it to the coefficient.
Yeah, so then you would know if it was adding it to the coefficient or just multiplying the two numbers together because they weren't quite sure.
The only thing I know that I use that helps a small proportion of people is to go ahead and write dots in between them. You know, 2 dot x cubed dot y cubed. It's subtle, I don't know why it works, but it does work. As soon as that's just a coefficient by juxtaposition, that's when they tend to make the error more often. So test it in your own classes. If you see this error, just say, hey, well, what do you think about 2 dot x cubed dot y cubed? And see if there's a change in the number of people who get it wrong. I don't know why that helps.
Well, or move your parenthesis, your left parenthesis behind the 2 and back and forth and see if they can figure that out too. It changes. Because if you move the
Yeah.
parenthesis behind the 2, you don't,
You mean like this?
there's no exponent. If you have it in front of the 2, then there's the exponent.
So compare and contrast two problems, is
Like
what I
this?
said. Yeah, so
This one?
yeah,
Yeah.
if you show them,
I think you would just say.
Mhm.
this. Yeah, just say, what is this? And then, what is that? And do you get the same thing? with both of those?
I think you're right, I think they realize that they shouldn't be doing the same thing. I don't know why my technique. It doesn't help enough people to solve the problem. We're talking minimal improvement here. But I'm surprised it works. For a small subset of people, it works.
So
I
what
know with
you're
our kids, if they
saying is-
understand that, if they understand to multiply the exponents, then put an exponent on the 2, put a 1 there, it's not 0.
Yeah, that's the other thing it fixes, it put a 1 on it too. So maybe it's just getting them to admit that it's multiplication between the number and the variable. Yeah,
So one is doing this, and what you were saying is maybe even, maybe I should put an or here. I feel funny not having an other equals, but I'm ingrained pretty heavily. So you're saying or write it as 2 to the first power times x cubed times y cubed, like that?
I wonder if those are different groups of people who it helps.
And just the idea that you write them next to each, like you expand that square in some way, like we were talking about before, that makes a big difference, I think, in what they.
I just think foundationally, that's right. I've noticed how much better my students are doing this area. If you build up to the rule, but you gotta start with foundation. Like if you just teach the rule, they're just all over the place.
So you're saying if we do this and then and whether we actually rate the dots in the middle or not. If we just rate that out before we tell them anything about a rule
Yeah,
and have them sort of discover.
but
oh,
that's
yeah,
just me from the very beginnings of teaching them exponents though. I mean, maybe if you've got freshman algebra students who've seen this a few times.
Hey, Kim?
She's disagreeing with you, I'm
Yeah,
pretty sure.
It doesn't matter. How do your students put the 0 there when you tell them to put the 1?
Hold on.
What now?
So if we try to help them by saying, hey, put an exponent of 1 on the 2.
Uh-huh.
How many of our students in practice the next day put a 0 up there? I guess that's in which case have we helped them?
Because I
But
don't
we've
have
generated a
exponents,
new
so-
discussion.
Oh, you don't.
We found
have
a new
it.
error.
So it's a
Yeah,
zero.
but then that's, but you can make a vertical table and
Yeah.
start with,
Right, that's fixed.
2 cubed is 2 times 2 times 2, 2 squared, and then 2 to the first is just 1, 2, 2 to the 0, and then you can show how you're just dividing by 2 to go backwards.
No, I'm not saying that they don't put a, I don't know what I'm trying to say. If it doesn't have an exponent, I'm gonna write a 0 there,
Right.
and you tell me to write an exponent there.
If there's not an exponent, it's a zero. Just hang with that something.
You're right, you can correct.
I understand how you correct it, yeah.
They're just trying to overgeneralize, because you
Right.
can add 0.
So, yeah,
Zero
but you can go back and say, well, if I have an x, how many do I have? Do I have 0x or do I have 1x?
Right.
That's the same concept.
But
Or
then
your
throw in
exponents.
like degrees of a polynomial in there, and I had 24 up there for kids who are just learning about the degrees of a polynomial, and they say 1. You know, so that's interesting to me too. You know, I would have thought, oh, there's no x's, it's 0, but nope, they said 1 because 24 to the first. So I thought that was interesting.
So is there a way to use this to deal with the power of 0 being 1, always equal to 1? Because that's the one I have more trouble with than anything, just trying to get that power of 0 is equal to 1. How do you do that?
You can use your table going backwards, divide. Another easiest, after you do that, probably the easy example I've done is like, take, after you learn the rules, you say x cubed divided by x cubed, and then write it out, x times x times x divided by x times x by x. They all cancel, so you get 1, and then you know the formula. It equals x to the 3 minus 3, which x is 0. So I show them that it equals both, it equals 1 and that.
I think the main struggle is they just don't see it enough, is what it comes down to.
I was gonna say.
Or they've only
place
seen
values
one
is
explanation.
And
two.
I
we've
mean,
heard
to me,
a
the
lot,
most powerful
One's
thing is
place
to
is
show
10
them
to the
all
0.
the
and you can
explanations.
build
we've heard a
it.
lot from this table, give